Welcome back to my YouTube channel. And today we will be designing Netflix or a video streaming platform. So this video will be very informative and little bit long. So stay tuned. I promise it will be very informative. Let's get started. Get started with functional requirement first. So uh, what will be our functional requirement? So what we will be building is we will building a platform where we can search, browse any movies or any show. We can play that video. We can get recommendations. The video should be supported on multiple devices, and also there should be a user history from where we have started watching all the our resume. If we have left it from somewhere, we can resume it, and obviously the subscription and billing. For non-functional requirements, I have picked up like our system should have low latency. We should able to search fast and play that video as soon as possible. It should be high availability and scalability. That means if our network, if our traffic increases, our system should be able to handle that much traffic. Okay, so we are building a system which will be globally distributed. A movie or show can be viewed globally in any part of the world. Plus, we want our system to have all the DRM compliance, and the content security should also be there. Let's get started. So, when we are talking about a video streaming platform, two main basic things are here. First is how we are saving that video, and second is how we are playing that video. Let's start with our content service, which will be responsible for saving that video. Okay, so we have a client here. Whenever here client is an admin. Okay, so whenever an admin want to upload any new video or any new movie, what it will say to content service, hey, I want to start an upload. So content service will make an entry in the database and give him a pre-signed URL. So what is this pre-signed URL? Pre-signed URL is a URL which can be accessed by client directly without any authorization for a particular period of time. So we have created a URL of our blob storage, for example S3, and given it to client. Now client will upload that video in that pre-signed URL, and as soon as that is uploaded, we will say to content service, hey, my video is uploaded of this ID, and we will provide the metadata of that video like title and images, thumbnail, these things, and then that content service will mark that entry as saved. And when that entry is saved in the database, we will push an event in Kafka. This Kafka queue will be consumed by messages from this queue will be topic that will be consumed by consumers, which will be responsible for encoding the video. By encoding, I mean, so there are different steps which we have want to follow. As you know, we want to support multi devices, so we want to have video which have all kind of resolutions. So our consumer will be responsible for make converting that video in all resolutions. Plus, we want to cut a video in different chunks. Let's suppose a video is 1 hour long. Okay, so we will be cutting it in chunk, like if it is a 5 GB or 1 GB movie, we will be making one chunk of maybe 50 KB. Okay, like this we'll divide small chunks and create an entry in our and save that chunk of that particular resolution type of that video inside our S3. So these are the S3 path. First we have video ID and the file name. Second is we have a new bucket of video chunks where ID is there. Video type is a resolution, and the chunk ID obviously where it will be saved. Okay, so where are we getting this ID and chunk ID? So this is a table which will look like, okay, so video table I have ID, Started will be the status whenever we'll get client will get pre-send URL. Then as soon as this ID upload API is hit, we will mark it as uploaded, and Kafka consumer will move it into in progress. And when all the processing of the consumer is done, we will mark it as saved. It will have the S3 URL and all the metadata. Video chunk will have the data of all the chunks. Okay. So this is our content service. So this content service is our persistent storage or single point from where we can get data uh, of all the content. Now comes to the playback service. So whenever you want to play a movie or a video, this playback service will come into picture. Okay. Now we'll see that how this playback service will come into the picture. Okay. Whenever you click on play, this playback service will ask content service to give data based on this video. So we will give them video ID, name, everything, all the resolution possible, all the and number of chunks also we'll provide in this only. So we will also have how many chunks are there. Okay, so we will number of chunks. Let's suppose we have 100 chunks. So all this information we'll give, and this information will be given to then our client. Okay, so we'll give that to our client. So what this playback service is doing? This playback service is responsible for multiple things. First of all, it will validate. Okay, it will get data from a content service. It will apply DRM, all the DRM rules, sign the URL, and then return to our client. Okay, so now what client will do? There are 100 chunks. It will divide the video player in 100 parts, and it will play that video of that chunk directly. So first approach is we can ask like, hey, this is the chunk ID. We will tell the playback service, and playback service will ask the URL from content service, and it will tell this is the URL, and then we'll get return that URL of that chunk to client, and client will download it from S3 and play. But this is not scalable. We'll come back on that later, how to scale this. So what this queue is doing here? This queue is responsible for publishing messages of which user is playing what, so that recommendation service, analytics, consumers, and our user history can consume these messages and save their data and perform their operations. So this is an event. We will just publish an event, and different services based on their requirement can listen these events and perform their operations. Okay. Now come to the bigger picture. What a complete design will look like. Okay. This is our content service. So what all it will do? It will convert into multiple formats. First of all, then break into chunk. Then after breaking it into chunk, it will pass through different again. So this is happening like it will convert into multiple. One second. Yeah, it will convert it into multiple formats, resolutions, and then again send a message to the different topic. Then that topic will be consumed by different consumer. It will break into chunk. Then again it will push a message. Then that data will be saved in S3 and DB, and then after it is done, we will save that message into CDN. So we'll pass these information to different services all across the world, and also save this into CDNs. Okay. So whenever playback service will ask for any video, we will return all the information to client, so that client can directly access CDN and get data directly. It will get data directly from CDN. It will not get the S3 URL. It will have that binary video. Binary video will be there. File will be there. So that binary data of that video chunk will be directly used by client, and then this client can push and event of what all video and at which part that user is, and that can be consumed by user history consumer, and it will save data in Cassandra. Why we have chosen Cassandra here? Because user history is something which can be which have high throughput of read and write both, and Cassandra is very much capable of handling these kind of traffic. Okay, so now our functional requirement was how we will manage able to resume playback download. So these messages consumed by in user history consumer, so it will know till which chunk we have already consumed, which or till which chunk we user has seen, so it will be resumed from that there only. Okay, we have user service also, and this user service is responsible for authentication and everything. Their recommendation service, analytics services, and one billing service. So this is a complete flow of uh, how user will be able to get data. Okay, and now if you see, we have already let's suppose there is high throughput. So what this client is doing, it is directly fetching from CDN. So we can add fallbacks for CDN, like if you don't have this video, it will get video from neighboring CDNs also. It can get video from neighboring CDNs as well. Okay, and if it is not there, then we can create a fallback. We can have a fallback service here as well, which is responsible for getting data for this CDN. So this CDN will call this service. So we can give it name as CDN fallback service. It will provide data to CDN as a fallback. Okay, so like this we can uh, build our Netflix or video streaming platform. I think we have covered all the functional and non-functional requirements here. Okay, I think we have covered a lot of topics here, like use of CDN, S3, how video is uploaded, how it is played. A lot of concepts were used here. Do let me know how did you like this video, and if you want me to create a video in any other design in future. Till then, take care.